Question 1. What is a primary benefit of adopting a microservices architecture for an MLOps system compared to a monolithic approach? Option A. It simplifies the overall system design and reduces operational overhead. Option B. It enables independent development, deployment, and scaling of individual ML pipeline components. Option C. It forces all components to use the same programming language and technology stack. Option D. It eliminates the need for continuous integration and continuous delivery, CI/CD pipelines. The correct answer is, it enables independent development, deployment, and scaling of individual ML pipeline components. Here's the explanation. Microservices allow each part of the ML pipeline, e.g., data ingestion, feature engineering, model serving, to be developed, deployed, and scaled independently, which is a key advantage over monolithic applications for agility and efficiency in MLOps. Question 2. Which two characteristics are fundamental to microservices architecture in MLOps, enabling loose coupling and independent scaling? Option A. Centralized database and tight inter-service coupling. Option B. Independent deployability and API-driven communication. Option C. Monolithic application structure and shared runtime environment. Option D. Manual infrastructure provisioning and infrequent deployments. The correct answer is independent deployability and API-driven communication. Here's the explanation. Independent deployability allows services to be updated without affecting others, and API-driven communication ensures loose coupling, both of which are fundamental to microservices and enable flexible scaling and development in MLOps. Question 3. An MLOps engineer is designing a real-time inference service that needs to scale independently and communicate with other services. Which set of technologies and communication patterns are best suited for this microservice? Option A. A single, large, monolithic application deployed on a virtual machine, using direct database calls for communication. Option B. A containerized service, Docker, deployed on an orchestration platform, Kubernetes, communicating via RESTful HTTP APIs or gRPC. Option C. A serverless function, Lambda, with a centralized enterprise service bus, ESB, for all interactions. Option D. A tightly coupled service sharing its codebase with the training service, relying on shared memory for inter-service communication. The correct answer is a containerized service, Docker, deployed on an orchestration platform, Kubernetes, communicating via RESTful HTTP APIs or gRPC. Here's the explanation. Containerization, Docker, and orchestration, Kubernetes, are essential for independent scaling and deployment of microservices. For real-time inference and inter-service communication, lightweight synchronous APIs like REST or gRPC are ideal. Question 4. What is the primary benefit of using Docker in an MLOps context? Option A. To automatically manage cloud infrastructure resources for model deployment. Option B. To provide OS-level virtualization for consistent and reproducible ML environments. Option C. To perform distributed training across multiple GPU nodes. Option D. To simplify the process of hyperparameter optimization for ML models. The correct answer is to provide OS-level virtualization for consistent and reproducible ML environments. Here's the explanation. Docker's core value in MLOps is encapsulating applications and their dependencies into isolated containers, ensuring reproducibility and consistency across development, testing, and production environments, thus solving the "it works on my machine" problem. Question 5. Which Docker component is a read-only template containing an application and its environment, and which is a runnable instance of that template? Option A. Docker file, Docker engine. Option B. Docker image, Docker container. Option C. Docker hub, Docker compose. Option D. Volume, network. The correct answer is Docker image, Docker container. Here's the explanation. A Docker image is the static, read-only template or blueprint that contains the application and its environment. A Docker container is a runnable, isolated instance created from a Docker image. Question 6. How does Docker achieve isolation and resource management for containers? Option A. By running a full virtual machine for each container. Option B. By using namespaces for isolation and control groups, C groups, for resource allocation. Option C. By relying on the host operating system's built-in process isolation only. Option D. By encrypting all container data and processes. The correct answer is by using namespaces for isolation and control groups, C groups, for resource allocation. Here's the explanation. Docker leverages Linux kernel features, Namespaces provide isolation by giving each container its own view of system resources, and control groups, C groups, limit and allocate resources, CPU, memory, I/O, to containers, preventing resource contention. Question 7. In the context of MLOps, what is the primary role of Kubernetes? Option A. To provide a robust framework for building and training machine learning models. Option B. To manage and automate the deployment, scaling, and management of containerized ML applications. Option C. To offer a centralized registry for storing and versioning trained ML models. Option D. To facilitate real-time data streaming and ingestion for ML pipelines. The correct answer is to manage and automate the deployment, scaling, and management of containerized ML applications. Here's the explanation. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications, including ML workloads. Options A, C, and D describe functions of ML frameworks, model registries, or data platforms, respectively, which Kubernetes can host but are not its primary role. Question 8. An MLOps team needs to deploy an ML inference service that can automatically scale to handle fluctuating request loads. Which Kubernetes component is primarily responsible for automatically adjusting the number of pods based on observed metrics? Option A, service. Option B, persistent volume, PV. Option C, horizontal pod autoscaler, HPA. Option D, job. The correct answer is horizontal pod autoscaler, HPA. Here's the explanation. The horizontal pod autoscaler, HPA, automatically scales the number of pods in a deployment or replica set based on observed CPU utilization or other select metrics, making it ideal for ML inference services with fluctuating loads. A service exposes the application, a PV provides persistent storage, and a job runs a finite task. Question 9. Which of the following statements accurately describes the relationship between Docker and Kubernetes in MLOps? Option A. Docker is an orchestration platform that manages Kubernetes clusters. Option B. Kubernetes is a containerization technology used to package ML models, while Docker orchestrates them. Option C. Docker packages ML applications into portable containers, and Kubernetes manages and scales these containers. Option D. They are competing technologies that perform the exact same function in MLOps. The correct answer is Docker packages ML applications into portable containers, and Kubernetes manages and scales these containers. Here's the explanation. Docker is a containerization technology used to package applications and their dependencies into portable units. Kubernetes is an orchestration platform that manages and automates the deployment, scaling, and networking of these Docker containers, or other OCI-compliant containers, at scale. They are complementary technologies, not competing ones, and their roles are distinct. Question 10. What is the primary benefit of using serverless inference for ML models in an MLOps context, especially for workloads with unpredictable and intermittent traffic patterns? Option A. It provides complete control over the underlying server infrastructure and operating system. Option B. It eliminates the need for any form of model monitoring or logging. Option C. It offers automatic scaling from 0 to thousands of instances and a pay-per-execution cost model, significantly reducing operational overhead. Option D. It guarantees zero latency predictions for all inference requests, regardless of idle periods. The correct answer is, quote, it offers automatic scaling from 0 to thousands of instances and a pay-per-execution cost model, significantly reducing operational overhead. Here's the explanation. Serverless inference's core advantages are automatic scaling based on demand, including scaling to 0 when idle, and a cost model where you only pay for actual execution, making it highly efficient for intermittent workloads and reducing server management overhead. Question 11. Which of the following is a common trade-off or challenge associated with serverless inference, particularly when deploying latency-sensitive ML models that may experience periods of inactivity? Option A. The requirement for manual server provisioning and patching. Option B. Significantly higher operational costs compared to VM-based inference. Option C. Cold start, latency, where initial invocations of an idle function take longer to execute. Option D. Inability to integrate with other cloud services for data storage or messaging. The correct answer is cold start, latency, where initial invocations of an idle function take longer to execute. Here's the explanation. Cold starts are an inherent characteristic of serverless functions, where the first request to an idle function experiences increased latency as the execution environment is provisioned and the model loaded. This is a key consideration for latency-sensitive applications. Question 12. An MLOps team needs to deploy a complex deep learning model with a large set of custom libraries and dependencies as a serverless inference endpoint. Which type of serverless offering would provide the most flexibility for packaging and deploying this model? Option A. Traditional serverless functions deployed via zip files, e.g., AWS Lambda with basic layers. Option B. Virtual machines, VMs, running on a dedicated cloud instance. Option C. Container-based serverless platforms, e.g., Google Cloud Run, AWS Lambda with container images, Azure Container Apps. Option D. Batch processing services for offline inference. The correct answer is container-based serverless platforms, e.g., Google Cloud Run, AWS Lambda with container images, Azure Container Apps. Here's the explanation. Container-based serverless platforms allow deploying custom container images, which can encapsulate complex ML models and their specific dependencies, offering greater flexibility than traditional zip file deployments for serverless functions. Question 13. Which of the following is a primary motivation for employing edge inference in an MLOps environment? Option A. To centralize all data processing in a single cloud environment. Option B. To maximize network bandwidth usage by transmitting all raw data. Option C. To reduce latency and enhance data privacy by processing data locally. Option D. To simplify model training by performing it directly on edge devices. The correct answer is, quote, to reduce latency and enhance data privacy by processing data locally. Here's the explanation. The overview states that edge inference significantly reduces latency, conserves network bandwidth, enhances data privacy by minimizing data transfer, and improves system reliability by allowing operations even when cloud connectivity is unavailable. Question 14. Which techniques are commonly used to optimize machine learning models for deployment on resource-constrained edge devices? Option A. Increasing model complexity and using larger datasets. Option B. Quantization, pruning, and knowledge distillation. Option C. Running models exclusively on cloud GPUs. Option D. Disabling all data preprocessing on the device. The correct answer is quantization, pruning, and knowledge distillation. Here's the explanation. The key features components, section lists, model optimization, techniques such as quantization, reducing precision of weights, pruning, removing less important connections, and knowledge distillation, training a smaller model to mimic a larger one, as crucial for edge devices. Question 15. In the MLOps workflow for edge inference, what is the typical first step before model optimization for edge deployment occurs? Option A. Directly deploying the unoptimized model to the edge device. Option B. Training the initial machine learning model in a powerful cloud environment. Option C. Performing real-time data acquisition and pre-processing on the edge. Option D. Sending aggregated results back to the cloud for monitoring. The correct answer is, quote, training the initial machine learning model in a powerful cloud environment. Here's the explanation. The How It Works section begins with model training in the cloud. The initial machine learning model is usually trained on large datasets in a powerful cloud environment. Question 16. Which type of scaling is generally favored in modern MLOps for its flexibility and ability to handle massive distributed workloads, especially for inference? Option A. Vertical scaling, scaling up. Option B. Diagonal scaling. Option C. Horizontal scaling, scaling out. Option D. Manual scaling. The correct answer is horizontal scaling, scaling out. Here's the explanation. The overview states that, in MLOps, horizontal scaling is typically favored for its flexibility and ability to handle massive distributed workloads. The exam tips also emphasize this distinction. Question 17. For model inference, which two components work together to distribute incoming requests and automatically adjust the number of model instances based on demand? Option A. Distributed training frameworks and data parallelism. Option B. Serverless inference platforms and model parallelism. Option C. Load balancers and auto-scaling groups. Option D. Monitoring systems and data versioning. The correct answer is load balancers and auto-scaling groups. Here's the explanation. The key features components, section lists, load balancers, distribute incoming inference requests evenly, and auto-scaling groups, managed instance groups, automatically adjust the number of compute instances. The How It Works section further details their interaction for inference scaling. Question 18. A data science team needs to train a very large model on an extensive dataset that cannot fit into the memory of a single GPU. Which distributed training strategy would be most appropriate for this scenario? Option A. Data parallelism. Option B. model parallelism. Option C, batch inference. Option D, vertical scaling. The correct answer is model parallelism. Here's the explanation. The How It Works section describes model parallelism, used for extremely large models that cannot fit into the memory of a single device. The model architecture itself is split across multiple devices. Question 19. In an MLOps scenario, a data science team wants to deploy a new version of their recommendation model, Model B, alongside the current production model, Model A. They wish to route 5% of live traffic to Model B to evaluate its performance before a full rollout. Which load balancer feature is most suitable for this strategy? Option A, round-robin algorithm. Option B, health check. Option C, SSL/TLS termination. Option D, content-based routing, application layer, load balancing, layer 7. The correct answer is content-based routing, application layer, load balancing, layer 7. Here's the explanation. Content-based routing, layer 7, allows the load balancer to inspect request details like HTTP headers or URL paths and route traffic accordingly. This is ideal for A/B testing, canary deployments, or routing specific percentages of traffic to different model versions based on the request content. Question 20. What is the primary purpose of health checks in a load balancer for ML inference services? Option A, to encrypt traffic between the client and the load balancer. Option B, to ensure that back-end ML model instances are operational and responsive before directing traffic to them. Option C, to evenly distribute requests using the least connections algorithm. Option D, to store session information for stateful ML applications. The correct answer is to ensure that back-end ML model instances are operational and responsive before directing traffic to them. Here's the explanation. Health checks are crucial for high availability. They periodically probe back-end instances to verify their health. If an instance fails a health check, the load balancer removes it from the pool, preventing requests from being sent to unhealthy endpoints and ensuring continuous service. Question 21. An e-commerce platform needs to handle millions of real-time product recommendation requests per second during peak sales events. Which of the following is a fundamental benefit that load balancing provides in this high-throughput ML inference scenario? Option A, it performs complex feature engineering on the incoming data. Option B, it offloads the model training process to the client devices. Option C, it distributes incoming network traffic across multiple back-end ML model instances to optimize resource utilization, maximize throughput, and ensure high availability. Option D, it automatically updates the ML model with new training data without downtime. The correct answer is it distributes incoming network traffic across multiple back-end ML model instances to optimize resource utilization, maximize throughput, and ensure high availability. Here's the explanation. The primary role of a load balancer in high-throughput scenarios is to efficiently distribute incoming requests across multiple back-end servers, ML model instances in this case. This prevents any single instance from becoming a bottleneck, optimizes resource use, and ensures the service remains available and responsive under heavy load. Question 22. Which of the following best defines inference latency in MLOps? Option A, the time taken to train a machine learning model on a given dataset. Option B, the total time from when an ML model receives an input request to when it returns a prediction. Option C, the duration required for data pre-processing before model training begins. Option D, the speed at which an ML model can process multiple requests simultaneously. The correct answer is the total time from when an ML model receives an input request to when it returns a prediction. Here's the explanation. Inference latency is defined as the total time taken for an ML model to process a single input request and generate a prediction or output, from initiation to result return. Option A is model training time, C is pre-processing time for training, or inference but not the total, and D describes throughput. Question 23. All of the following factors directly influence inference latency except Option A, model size and complexity. Option B, network latency between client and inference service. Option C, data pre-processing time. Option D, model training time. The correct answer is model training time. Here's the explanation. Model training time is the duration required to train a model and occurs during the development phase, not during the model's active prediction, inference phase. Model size, network latency, and data pre-processing time are all key contributors to overall inference latency. Question 24. An MLOps engineer is tasked with optimizing an online fraud detection system that needs to respond within milliseconds. Which of the following strategies, while potentially improving throughput, could negatively impact the latency for individual requests. Option A. Deploying the model on edge devices closer to the data source. Option B. Using a larger batch size for inference requests. Option C. Quantizing the model to reduce its size. Option D. Utilizing specialized AI accelerators, e.g. GPUs, for model computation. The correct answer is using a larger batch size for inference requests. Here's the explanation. While larger batch sizes can improve throughput by processing multiple requests concurrently, they can also increase the latency for individual requests as the system waits to accumulate enough inputs to form a batch. Options A, C, and D are all common techniques to reduce latency. Question 25. Which metric is the primary measure of throughput for an ML inference endpoint in an MLOps production environment? Option A. Mean absolute error, MAE. Option B. Latency, milliseconds per request. Option C. Requests per second, RPS, or inferences per second, IPS. Option D. Model accuracy percentage. The correct answer is requests per second, RPS, or inferences per second, IPS. Here's the explanation. Throughput measures the rate at which an ML system can process data or requests. For inference endpoints, this is directly quantified by how many predictions or requests it can handle per second. RPS, IPS. Latency is the time for a single request. And MAE/accuracy are evaluation metrics, not throughput metrics. Question 26. An MLOps engineer is optimizing a deployed model. They increase the batch size for inference requests. What is the most likely trade-off observed from this action? Option A. Decreased throughput but increased model accuracy. Option B. Increased throughput but potentially increased individual request latency. Option C. Decreased latency but increased memory consumption. Option D. No change in throughput, only reduced CPU utilization. The correct answer is, quote, increased throughput but potentially increased individual request latency. Here's the explanation. Batching groups multiple requests, allowing hardware like GPUs to be utilized more efficiently, which typically increases the overall throughput. More requests processed per second. However, each individual request within a batch might wait for other requests to accumulate before processing, thereby increasing its individual latency. Question 27. Which of the following MLOps practices is most directly aimed at dynamically adjusting resources to maintain high throughput during varying loads? Option A. Feature engineering. Option B. Model versioning. Option C. Autoscaling and load balancing. Option D. Data quality monitoring. The correct answer is autoscaling and load balancing. Here's the explanation. Autoscaling dynamically provisions or deprovisions model instances based on demand, while load balancing distributes incoming requests across these instances. Together, they ensure the system can handle fluctuating loads and maintain desired throughput levels without manual intervention. The other options are important MLOps practices, but do not directly manage dynamic resource adjustment for throughput. Thanks for watching. Please subscribe to my channel.